So in this practice SAT problem, they give us an equation and they say that in that equation, C is a constant. The equation has no real solutions if C is greater than n. What is the least possible value of n? Now, if you look at this and recognize that it is a quadratic equation, you can use the quadratic formula to solve any quadratic equation after it's set equal to 0, which this one already is. And what indicates that a quadratic equation has no solution is when you have to try to do the no real solution, I should say, is when you have to try to take the square root of a negative in this spot right here. So if b squared minus 4ac, which is oftentimes referred to as the discriminant, if that is negative, you have no solution, no real solution. I'm going to compute b squared minus 4ac. I'm going to compute the value of the discriminant. So I'm going to take b, which is the coefficient of x, minus 4, 1 is the coefficient of x squared, and then c is the constant that's just prior to the equal sign. If I square negative 34, I get 1,156. I would want the discriminant's value to be less than 0 in order to have no real solution. So if I solve this equation, I can add the 4c to the other side. I can divide both sides by 4, and I get that 289 would have to be less than c, or c would have to be greater than 289 in order for my discriminant to have a negative value. So what is the least possible value of n? Well, c is going to have to be greater than 289, so n, the least possible value for it for this situation, would be 289.